All right, so we are moving into Chapter 2, Section 2. We're talking about normal distributions and using the empirical rule. So our goal today is to be able to understand and apply the empirical rule to estimate areas in a normal distribution. So as we go through this lesson, be thinking about what the empirical rule is and how do we use it to estimate percentiles. So by the end of this lesson, you should be able to do these two questions, be able to talk in general about the empirical rule, and then apply the empirical rule to find specific values. So our only vocab today is the empirical rule, so let's talk about it. So the empirical rule is also known as the 68, 95, 99.7 rule, and this basically provides a quick estimate of the spread of data in a normal distribution given the standard deviation and the mean. So all it's saying is that 68% of my data is going to fall between one standard deviation of the mean. So one above and one below, 68%. So over half of my data should be within one standard deviation of the mean in a normal distribution. So if 68% of the data is between one standard deviation, how much data would be outside of that one standard deviation? So if 100% of my data is underneath this curve, because it's a density curve, and 68% is here, 100 minus 68 gives me 32. So 32% of my data is outside of one standard deviation. And so if this is a symmetric bell curve, that would leave what percent in this area, so below, so more than a standard deviation below, and what percent above, or more than one standard deviation above. So if 32% is outside, so either direction, what percent would be below and what percent would be above one standard deviation? So hopefully you were able to realize that those two spaces are equal. And so if I took 32 and divided in half, that would leave me 16% above and 16% below. But what we're talking about here is that 68% of my data is between one standard deviation of the mean. All right, so the empirical rule is the 68, 95. 99.7 rule. So that means that 95% of my data is between two standard deviations of the mean. So we have the 68 right here, and then we add on a little bit more that's within that next standard deviation. So 95% of my data is between two standard deviations away from the mean. So that only leaves me with 5% of my data outside. So 5% of my data is outside of two standard deviations. That would leave me with 2.5% here and 2.5% here because it is a mirror symmetric image. And then the last part of the empirical rule is that 99.7, so almost 100% of my data should fall within three standard deviations of the mean. So between -3 and +3 standard deviations away from that mean should be almost all of my data, so 99.7%. So that would leave how much data falling outside? 0.3%, not 0.3 because that's 30%, but 0.3% because this is almost 100%. So that's what we talked about yesterday, where almost all of my data will always fall between three standard deviations of the mean. All right, so you're going to have a lot of questions that are going to ask you to use the empirical rule, and it'll ask specifically between maybe two standard deviations away from the mean and one standard deviation below the mean. So what's going to help us is if we can divide and figure out what percent fall in each of these sections, that will allow us to quickly and easily answer these questions. So let's think about this. This is symmetric. The mean is in the middle. If 68% of my data falls between one standard deviation above and below, what percent would be here and what percent would be here? So pause the video and think about that. So hopefully you were able to figure out that 34% will be from the mean to one standard deviation below, and 34% will be from the mean to one standard deviation above, since 68% of the data lies between those two and it is symmetric. So I take that and divide it in half. All right, so this is where it gets a little bit trickier. So remember, 95% of my data is between 2 standard deviations from the mean, okay? So if 68% is right here, that leaves me with how much to be here and here? Well, it's going to be 95%, the distance from -2 standard deviations to 2 standard deviations, minus the 68 that we already know exists. And then we'll divide that in half, and that'll tell us what is between -1 standard deviation and -2 standard deviations, and between 1 standard deviation and 2 standard deviations. So 95 minus 68 gives me 27, and when I divide that by 2, I get 13.5. So there'll be 13.5% of my data will fall here, and 13.5% of my data will fall here. And I can always double check, because 13.5 plus 68 plus 13.5 equals that 95% that fall within 2 standard deviations of the mean. All right, so when we talk about the 3 standard deviations, so we have the 68, 95, 99.7 rule. So 99.7% of my data falls within 3 standard deviations of the mean. So if 95% is within 2, that will leave me what to be outside of those 2 standard deviations, but still within this 99.7%. Well, 99.7, which is this whole distance, minus what we already know, the 95% that we've already accounted for, is going to give me 4.7. And then I know that's 4.7 divided among these 2 spaces. And since they're even, I'm going to divide it by 2, and I get 2.35. And I can always double check by taking 2.35 plus 95 plus 2.35, and that should give me that 99.7 that is within 3 standard deviations of the mean. And lastly, if I know that 100% of my data falls underneath this curve and 99.7% falls within 3 standard deviations of the mean, what would that leave me for these teeny tiny tails out here? So 100% of my data minus 99.7 gives me 0.3%, not 30%, but 0.3%. And then I know it's being divided by those 2 spaces, so that leaves me with 0.15%. So putting that all together in a more visually appealing style, we see that these are the different percentages that fall in the different spaces. And so we can always check, because 1 standard deviation of the mean is going to be 34 and 34, which is 68. So that's the first part. 13.5 plus 34 plus 34 plus 13.5 gives me 95, which 95% of my data is between 2 standard deviations. And then if I add those up, I get 99.7, and then if I add all of them up, I should get 100%, because 100% of my data falls below that curve. So that might be a little confusing. We'll talk more about it tomorrow, but just make sure you have a drawing and that you have these percentages divvied up, because that will make your life easier when you go to do these practice problems. All right, so let's apply the empirical rule. So I know the 68, 95, 99.7 rule fits. So I took and divvied it up in the nice easy percentages, because it's going to make my life easier. So the mean of young women's heights is normally distributed, that's what that means, with 64.5 is the mean and 2.5 is the standard deviation. So I'm going to go ahead and I'm going to label it on my graph. So the mean is 64.5. And I know that the standard deviation is 2.5. So I'm going to go ahead and label everything. So 64.5 plus 2.5 gives me 67. And then 67 plus 2.5 gives me 69.5. And then 69.5 plus 2.5 gives me 72. So that would be 3 standard deviations above the mean. And then if I go 2 standard deviations below, 64.5 minus 2.5 gives me 62. And then 62 minus 2.5 gives me 59.5. And then 59.5 minus 2.5 gives me 57. So I know that 99.7% of my data is going to fall between 57 and 72 inches. So 99.7% of women should fall between those two heights. All right, so let's apply this. If a woman is 64.5 inches tall, what percentile is she in? So remember, percentile is what percent of the data falls below. So I'm going to go and find 64.5, which happens to be my mean. And so my mean is everything below, or my mean is the halfway point. So that would mean that 50% of my data is below and 50% of my data is above. So she's in the 50th percentile. All right, the next question. What percentile is a woman who is 59.5 inches tall? So I'm going to go over to my table and I see that 59.5 inches tall is going to be 2 standard deviations below the mean. So percentile is everybody who is below that person. So if we're looking specifically at 59.5, that would leave me with 2.35% of the data below, and then another 0.15% outside of 3 standard deviations below. So from this point and below, I'm just going to do 2.35 plus that 0.15. And that gives me 2.5%. So she is in the 2.5 percentile or 3rd percentile if we round up. Oftentimes with percentile, you round up to the nearest whole. So we'll say the 3rd percentile. Which makes sense because most of my data is going to be within that 2 standard deviations from the mean, and she's at 2 standard deviations. All right, what percent of women are between 59.5 and 64.5 inches tall? So I'm going to show you a couple different ways that you can answer this question, and whichever way makes sense to you, that's the way you need to choose. So we're looking between 59.5 and 64.5. So what I can do, the first approach, the most straightforward, is to recognize that the 2 percentages that are between that are 13.5 and 34, because we're talking about this height and this height. So I could simply add 13.5 plus that 34%, and that gives me 47.5%. Another approach that I could have to it is I could think about, I know that 50% of my data is below 64.5. So that would be every height below 64.5. I also know from this previous problem, I know that 2.5% of the data is below that 59.5. So if 50% is below 64.5 and 2.5% is below my lowest, I could simply take 50% and subtract out these two pieces right here, and then that would tell me what is between 64.5 and 59.5. So the other approach would be to say 50 minus 2.5 also gives me 47.5%. Either way, whichever one makes sense to you. And the last question. What percentile is a woman who is 67 inches tall? So 67 inches is 1 standard deviation above. So we're talking about percentile, so we want everything below. So there's also 2 ways we could figure this out. So 67% would be this 34%, this 34%, this 13.5, this 2.35, and this 0.15. So I could add all of those up, and I would get 84%. Or I could use that same thinking that we talked about. I know that 50% of my data is on this lower half right here. So 67 is all of that plus 1 standard deviation above. So I could end up taking the 50% that I know is below the mean and just adding on that 34%, and 50 plus 34 also gives me 84. So what percentile? She would be in the 84th percentile. All right, that is all for this lesson. It's pretty straightforward. It just takes a lot of analyzing that bell curve and memorizing that 68, 95, 99.7 rule. So go ahead and pause the video and have an interaction. What did we just talk about? What do you need to remember? What questions do you have? Especially when it comes to that application piece. So being able to look at the bell curve and determine percentages when I know exact standard deviations. So exactly 1, 2, or 3 above or below. And here's our only vocab word.